In this talk, he will share a cosmological narrative of the human journey with speculations concerning its near-term culmination in the emergence of a noosphere, a united humanity. Can't think of a more appropriate theme for our evening together after this long and devoted day. I'll just say one more thing, which is the first time I heard Brian speak from the pulpit of the cathedral, he was sharing, as he will tonight, the unfolding of the creation story of the universe. And I was weeping as I heard him speak, and I thought, he speaks it with the sacredness, holiness, and reverence that a rabbi reads scripture. He speaks the language of the universe as if it was Torah. So Brian, we're unbelievably privileged and thrilled that you agreed to call in and be with us tonight, and I welcome you with the widest embrace and a lifetime of gratitude for your teaching and your vision, and I'll turn the stage over to you very happily.
Thank you, Amy. That means a lot to me. It really does. We've been friends for many years, and it's an honor to be part of your celebration. I really am thrilled to be here. I wanted to start off just to give you a sense of where I'm coming from, so that I don't come across as a know-it-all professor. So I'm working now with a human energy. Really a fabulous gathering of scientists and philosophers and other creative thinkers, and we've come together to explore the notion of the noosphere. Now, the noosphere is would be the primary subject of my presentation, but I recognize it's not a well-known concept. So I will do my best to make it straightforward. But I wanted to say that even though this group of scientists and philosophers is focused on understanding the noosphere, the truth is that we don't understand it, and we have insights into certain parts that I hope will interest you, and we certainly find them fascinating. But because the noosphere is emerging in our time, it's very difficult to have a comprehensive vision of it. But we can talk about ways in which we are inside the noosphere. So the title of my talk is The Third Story of the Universe. And that automatically brings up the first question. What's the first story and what's the second story? So just briefly, the first story, we are looking at the traditional accounts of the universe all around the planet, back into the earliest days of humanity, and we're just classifying those as the first story. But just to give you a sense of it, Copernicus, who is one of the early scientists, he in a certain sense summarized how small our knowledge was of the universe just 500 years ago. Yeah, you have to keep in mind, we've been here for 200,000 years with the same brain and the same anatomy. I mean, it's so stunning to think we've been here for this 200,000 years, and yet only recently have we made these amazing insights concerning the physical structure of the universe. So Copernicus, he drew a picture of the sun, and then the planets going around the sun, and then there were the stars in the background. That's it. And the stars were regarded as nearby. One of the narrators of the first story was pondering the stars. And this is what he came up with. If you gathered a huge number of people at night and you had them all shout at the same time, you would hear the echo off the stars. This wasn't just some narrator. This was one of the most brilliant thinkers of the time. But you see how cozy that world is? And another line that just captures to me how different the first story is came from a man in Africa when he was discussing the nature of the universe and the stars being nearby. And then the question was, well, what's beyond the stars? And he said, well, God is right behind the stars. And then the question was, well, what is God doing? And the man said, he's watching me. Now that is, again, like I say, it's a cozy universe. So then we had the second story. The second story was the eruption in human history of mathematical and empirical science. And we arrived at following Isaac Newton and others. Isaac Newton up to Albert Einstein, in a certain sense, is what gave rise to the second story. The second story is a vision of the universe that is controlled by physical laws, gravitation, electromagnetism, and so forth. And it's a universe that is the complexity in the universe is accidental. Okay, so now we come to the third story. And like I say, we humans are in the midst of putting together the deep and impressive insights of the first story with the undeniable truth of some of the aspects of the second story. So the third story can be considered a synthesis coming out of reflection upon what we have established as important concerning the universe. But let me repeat for one last time. This is, in a certain sense, a vision of the universe that it's obviously incomplete, that I'm going to provide. It's incomplete. There's so much more we need to understand. So I just want you to recognize the tentative nature of what I'm about to say. Let me start off with a bold statement. The fundamental difference between the third story and the second story is our discovery of self-organizing dynamics. So it's the switch from the idea of these laws controlling passive matter. It's a switch from that view to the discovery of these amazing self-organizing dynamics that are intrinsic to matter. That's the switch. And we'll return to it a number of times, so that should be clear. Here's the second main difference between the second and third stories. In the third story, we believe we have discovered a primary direction the universe is taking. Rather than a universe that's random, going this way and that, we now have empirical evidence that suggests the universe is heading towards something. And to bring this home a little bit, what we are hypothesizing is that the universe, as represented by planet Earth, is aiming at bringing forth the noosphere. And I know I haven't described it yet, but let me just take one more step and describe the noosphere as an envelope of thought surrounding the Earth that is guiding and in some ways controlling the evolution of the planet. Okay, now I'm going to say a few words about humans and chimpanzees. I mean, this is humans and chimpanzees are approximately 99% identical at the level of DNA. We didn't know this until recently. No one in the world of biology would have guessed this, because we would see our differences being so great. I mean, look at this weird species, or this beautiful species, however you want to say it, Homo sapiens. Over the last 100,000 years, we've invented symbolic language. We've discovered the biology of our bodies. We constructed 10,000 cities. We built libraries all around the planet, as well as communication satellites that potentially put each person in touch with every other person on the planet with the internet. Now, during that time, our cousin, the chimpanzee, stayed in equatorial Africa, happy, at home, perfectly content, while we were doing all these things. So and if we're 99% identical at the level of DNA, what is the difference? Now, I need to immediately say this. I am not suggesting that humans are more important or more valuable than chimpanzees or other species. The whole community thrives because of the different value that each species brings. That isn't my point. What I'm concerned to convey is this amazing change that took place with Homo sapiens. There are fruit flies. I even memorize the names for you. Drosophila heteroneura and Drosophila sylvestris. Two different species of fruit flies. They are further apart genetically than we are from chimpanzees. Now, you can imagine these two different species of fruit flies. They're flying around on fruit and all the rest of it. You can think that because they are so similar, their actions are not going to be that different. But then you come to the human in this amazing explosion. So now I want to dive into my exploration of this difference. And I want to do this with a number of images. So let me shift right now. Good. Okay, so we're beginning with the Paleolithic humans 50,000 years ago. And I want to emphasize that going into caves. Now, some of our early ancestors lived in caves. I'm not talking about those. I'm talking about the caves that were thousands of feet beneath the surface of the earth. And the question has to be asked, why would our ancestors, struggle down there in the dark on their backs, and they have, this animal fat torch to keep some light going. That must have gone out sometimes. They must have felt stranded. And I mean, just the thought of doing that, there must have been some huge reason. So normally in biology, we would talk about what they need is free energy, so they need food. There was no food down there. Or they needed to replicate sexual reproduction. There were no sexual mates down there. So they were about something different. And we don't know for sure. How could we? But there are different theories, and the theory I'm presenting here comes from Wolfgang Seidel at the University of Cologne in Germany. And he hypothesized that these early humans are participating in the evolution of their own mentality. And in what way? So and exactly what do I mean by that? Let me go to the next cave picture here. Now this is a little bit confusing, and I chose it because of that. Forget about the person there, but what we see is rock wall, and then there's this ochre material, this red material has been placed on it as well. So what, archaeologists studying this very carefully have been able to identify the kind of pigments that were used and the way in which they were, the way in which the Paleolithic humans marked up walls. They used sticks that had been burnt, and they used the charcoal to make dots and lines. They also would fill their mouths with a black ink-like material and spit on the wall. And so that, but I'm trying to emphasize the fact that they did this huge struggle to get underground and watch people spit on the wall and jab it with a stick until suddenly a horse leaps into their consciousness. Now, we come afterwards, so we go, well, of course it's a horse. What's the big deal? The big deal is that all they did was make marks on the wall, and suddenly the assembled group was experiencing again a memory of experiencing a horse, seeing a horse. So this invention of the symbol transformed not only humanity, but ultimately the entire planet Earth. Because now, why? Because now, two things. Number one, we had learned a way of storing information, storing knowledge in a form that would endure outside of our consciousness, so that one generation of humans could transmit knowledge into the future, into the far future even. And the second reason is that what this accomplished was it enabled a group of humans to share in the same experience. So together they are experiencing the horse or the mammoth or the antelope. And this changed things so dramatically because it enabled a bonding to take place that otherwise wouldn't happen. To give an example of this, just imagine a wildebeest in Africa going about its day, and it has this adventure which is terrible and beautiful at the same time. It's attacked by a bunch of lions, and that it gets wounded, it gets clawed, but it finds a way to escape. It kicks one of them and then frightens another and backs away and jumps, and who knows what happened, but it makes it back. It makes it back to its herd, and its friends come up. They recognize, they know what it feels like to be scarred, and they see the blood, and so there's empathy. There's empathy for this wounded friend, but they cannot ask what happened. And he cannot say, I learned something amazing. If you do A, B, and C, you can escape a group of lions. You gotta check it out, you know? And he also he can't express the traumas he's gone through. So that remains bottled up inside of him. But that is what humans figured out. They figured out how to express their feelings and their story through time. And we humans, we identify ourselves so profoundly with our experiences and our journey. And we've found a way to express that. So we have found a way to enter into a relationship with another human, with another group of humans, that is unlike any relationship in the history of life. Now, I recognize how bold that statement is and how strange it might sound. But let me just develop it a little bit further. What we have discovered examining 3.5 billion years of life is that when a species moves away into a different biome, it will develop into a new species. And this fanning out has led to the immense diversification in life. But bizarrely, humans began to spread out in Africa. They spread out throughout all of the continent of Africa. Then they spread east and west to the Americas and to Asia. And when they met in Hawaii, they were still the same species. Why? Because they had, instead of differentiating themselves at a very deep level from other humans, they found a way to bond and to relate and to recognize the deep similarity. Now, this is so unusual in biology. It's so unusual that scientists like the biological anthropologist Terence Deacon at the University of California, Berkeley, he makes this bold statement that humans, with the capacity of symbolic language, humans amount to a new phylum in life. The last time a new phylum of life appeared was 500 million years ago. So what we're learning is that in order to understand Homo sapiens, we have to recognize that we have a significance that matches somehow 500 million years of evolution. Why? Because of this twofold power we've been given. The power to learn and send knowledge down through the generations, and the power to bond so deeply we recognize our unity and in a profound level. So this brings us to the last great scientist in the second story, Albert Einstein, there on the left. And he is, this is an amazing moment. It's just an incredible moment. He's actually down in Southern California on Mount Wilson, and he's looking through what was then the largest telescope in the world. To his right is Edwin Hubble. Edwin Hubble was the person who discovered that the galaxies in the universe are expanding. Now, but here's the backstory. Albert Einstein, an incredible genius, as we all know, when he was in his apartment in Berlin, he articulated what we call the Einstein field equations. And they're used by cosmologists all over the planet to analyze the movement of galaxies throughout the universe. But what is strange is that when he came up with the equations and he examined them, he saw that they predicted that all the galaxies were moving apart from each other. Now, because there was no evidence whatsoever of this, Einstein simply altered his equations to take away the prediction of the expansion. This was because his view of the universe was entirely in what we now call the second story. Namely, the universe as a whole is static. Then things inside the universe might change, but the universe itself is the same today as it was yesterday and in the future. It's static. So he altered his equations to take away this prediction of expansion. But then Edwin Hubble actually saw the expansion through his telescope, and he invited Albert Einstein to come down and take a look himself, and he did. Now, and he quickly, because he was convinced by the evidence, he realized that he had been wrong. He regarded the change of his field equations to take away the prediction of the expansion as one of the worst scientific blunders of his life. I guess I'd like to focus on Einstein's creativity because it might be of interest to you in your own work. When he was examined by psychologists, interviewed, they asked him about his creativity. And he said something that surprised the psychologists. They were used to scientists referring to mathematical analysis or geometry or hyperalgebra or whatever advanced field they may be working in. But Einstein said something entirely different. He said, my creativity is more of the muscular type. He also used the word visceral. In other words, he felt his way into the dynamics of the universe, and then he gave expression to them. And this, because we now understand that our bodies are pervaded by gravitational interaction, electromagnetic interaction, the strong nuclear interaction. We can now see that Einstein's creativity can be considered the way in which the fundamental dynamics of the universe gave an expression of themselves through Einstein. And this is an idea we'll return to later. But what did Einstein see? Now, this is actually, Einstein didn't see this. This was only possible with our advanced telescopes coming after Einstein. But this is an image I want to just dwell on and to try to take in. We've been humans for 200,000 years. Not one generation in the past saw this. Every particle of light that you can see in this image is a galaxy. Each one containing, on average, 50 billion stars. And on average, 100 billion planets. I mean, the vastness can be crushing. It's almost too much. We can understand why people want to block out this knowledge because it makes us feel so insignificant. But actually, by dwelling on this further, scientists have discovered something that is profoundly counterintuitive. And I want to, because it's such a radical insight, I want to cite the cosmologist who came up with it, Stephen Hawking. Most of you know Stephen Hawking as the most celebrated mathematical cosmologist of the 20th and early 21st century. And what he came up with was the realization that all of these galaxies were expanding at exactly the rate necessary for life and complex order to emerge in the universe. It is the expansion rate then can be considered, I mean, some people would say the word sacred. It is certainly, I would call it one of the most surprising discoveries in the history of science. Let me just say it one more time, and then we'll move on. But if the expansion, this is what Stephen Hawking discovered mathematically, if the expansion were slowed down just a little bit, even a trillionth of a trillionth of a trillionth of 1% slower, the universe would have expanded for 1 million years and then collapsed down into a black hole. And the other direction is just as precise. If the universe has expanded slightly faster, just a trillionth of a trillionth of a trillionth of 1% faster, the universe would have expanded too quickly for stars and galaxies to form. It would have ended in just a vast, cold dust. Now, another amazing scientist, and that reflected on this is Freeman Dyson. Freeman Dyson is one of the most amazing physicists in the history of science, and he had a great phrase for capturing this discovery of Stephen Hawking. He said, "The universe from the beginning must have known that life was coming." Now, exactly what that means to say that the universe knows, that clearly would require, a tremendous amount of investigation. But I simply wanted to bring home this idea that the vastness of the universe is actually an outer sign of the intense complexity of a living animal. It took a universe this vast to bring forth the complexity we live within. Now, I wanted to go back to the point I said. One of the primary differences between the second and third story is self-organizing dynamics, and this spiral galaxies in general are such a wonderful illustration of what I mean, what scientists mean by self-organizing dynamics. We didn't know there were other galaxies in the universe. In the early 20th century, we did not know. Now we know there are at least 2 trillion. But this, the chasm that we've crossed in terms of knowledge. So when we first saw these galaxies, the scientists hypothesized that a galaxy was kind of like a pinwheel. It was spinning like a pinwheel. But then when they deepened their analysis of the galaxy, what they realized is that those arms are not physical. It's not like an arm made up of matter that's moving around. It's not. It is rather a density wave. It's a wave that as it sweeps through the galaxy, it ignites star birth. So as you look at one of the arms, either one of those two giant arms, you see all these red dots and all these stars. That's the density wave igniting powerful, brilliant stars, which burn out quickly. But then the wave moves on and ignites new stars, which burn out. Then it moves on and ignites new stars. So the density wave is the evidence of the self-organizing dynamics of the Milky Way. It wasn't that some huge creature, created it. The Milky Way created itself. It generated its structure by itself. When this was first dawning in the minds of physicists, some of them said the closest analogy we have to a galaxy is the living cell. Just like the cell will organize itself, so too will a galaxy. This is Eta Carina. It is a star in its last phase. And what is happening is that it's dispersing everything that it has created into the universe. The first stars were composed entirely of hydrogen and helium. But a star will create the other elements in its core. And so this is Eta Carina is a higher order star. And so it has brought forth carbon, nitrogen, sulfur, titanium. It has brought forth all of these elements and then is releasing them into the universe. So our interpretation of this is that the events in the universe organize themselves and participate in the ongoing development of the universe. So the systems that grow out of what Eta Carina releases contain rocky planets because Eta Carina has created the elements needed for a rocky planet. Now, this is to see a star as part of an ongoing development of the universe. That is, again, what is different with the third story. Before stars were there, they blew up, whatever. But now there's an overall movement of the universe. And the movement is towards more complex communities. So Jupiter, coming out of assembling itself in the solar system, 4.5 billion years ago, is a gaseous planet, and it will remain a gaseous planet. And with the right kind of spaceship, you could fly right through it. So, because I was mentioning the Eta Carina's creativity was released in order for the universe to advance, but there's also an element of chance involved in terms of how far the advance will go. Jupiter will remain this way as a gaseous planet. It's fantastic. I'm not complaining, but the reason it remains gaseous is because the gravitational pressure is so great. Any chemical creativity that starts to build a solid basis is ripped apart. On the other hand, we look at Mars. Mars is much smaller than Jupiter. And here the balance is tilted toward the electromagnetic interaction. The molecules that have bonded together electrically on Mars are too strong for the gravity of Mars to break down. So Mars has been frozen for at least 1 billion years in terms of its planetary dynamics. Now, I want to emphasize something that leads to my next point. All of the chemical elements are in Jupiter. All of the chemical elements are in Mars. The exact same chemical elements are in Earth, with one major difference. On Earth, the electromagnetic interaction is balanced with the gravitational interaction. And because of this, there is an ongoing mixing of the elements. It's the mixing of the elements in the churning of Earth, with its lava, right? And its planet, and its continental drift, and its the movement of chemical elements from the center of Earth out to the surface. All of that mixing is what gave rise to life. So no one came to Earth and fashioned life. Earth brought forth life because of the freedom of its ability to mix, to mingle, to bond, to explore, to discover. So going back to Mars, I mean, one of the things that when I first just learned all of this, I asked myself the question, what music is locked up in the rocks of Mars? The same elements brought forth Beethoven's symphonies on Earth. So what is that? What is there in Mars? I'm saying this because the third story leads to a reverential relationship with matter. We understand now the significance of the creativity that's intrinsic to matter. One of the challenges to enter the third story, as opposed to just knowing the facts, one of the challenges of entering the third story has to do with the notion of intelligence. Now, I have been trying to hint at another form of intelligence. And it doesn't even have a name right now. If I call it cosmic intelligence, it sounds too, flaky and ethereal. But it's my definition, my working definition is this primordial intelligence, let's call it. Primordial intelligence is the capacity to create complex communities. So I want a definition that's outside of the human world. I want it to be lodged in the universe as a whole. So the capacity to create complex community, that capacity is something like primordial intelligence. And I had an early experience of this question of intelligence, and I bring this up because I believe that all of us have experiences like this in a different form. So I was with my dad, and we went down to a creek, and these are sockeye salmon, and we went down there when the the sockeye were fighting their way up. I'm in the Northwest, Pacific Northwest. And I mean, it was amazing. They were fluttering. I could be real close to them. And so I was in the water, and my dad was telling me about this miracle of the salmon, coming back to the place of its birth. And he told me it might have been over in Japan a few months ago. So it's thousands and thousands of miles. It's been swimming around the Pacific, and it comes back to its exact place. I'm just taking this all in. We're walking along he's on the shore, I'm in the water. And then it was time to go home. And so we start heading home. And I sort of walk along. Suddenly my dad stops and we reverse directions. And we go back the other way. And then it suddenly dawned on me, even though our car was no more than 500 yards away, my dad and I were lost. And these fish just traveled thousands of miles to find their way home. So that is the fish have a kind of intelligence. The mosquitoes have a kind of intelligence. Humans have a kind of intelligence. And altogether, it is an expression of a primordial intelligence that is at work throughout the universe. Now here, speakers, you put a lot of work into preparing, and many of you are speakers, and you know what I mean. And we often wonder, what's the one takeaway? What will be remembered in my talk? And we've come to that point. So thinking about primordial intelligence, thinking about the capacity to bring forth complex community, we have this illustration of this lava. It's in Hawaii. All the rocky planets began as molten rock. So here we are, molten rock. And this gives birth to this. Not one different chemical element exists in the orangutan that is in the lava. It's exactly the same chemistry, exactly the same chemical elements. And yet, this lava gives birth to this. Look at the eyes of the orangutan. You see the light there, the sparkle. The lava gave birth to its intelligence. The lava gave birth to its consciousness. I believe that this will be the primary ritual of the future, will be to have a felt sense of the nature of the creativity in which we live. Now, this is an image that I want to use as a way of indicating the noosphere. So now I'm going to define it more thoroughly. When we look at the development of Earth, it begins as molten rock, the geosphere. And by the mingling that takes place, the molten rock gives birth to life, which then covers the whole planet, the biosphere. And then the biosphere, through its complexity, the development of brains and brains of brains, gives birth to Homo sapiens that spread around the planet and give birth to the noosphere, the thinking layer of Earth. Thinking. So it's and the way in which Pierre Teilhard de Chardin, the paleontologist and Jesuit who invented the idea of noosphere, the way he said it was very nice that the transition we're in is we're moving from a living planet is transforming into a thinking planet. Now, I want to bring us back to the Paleolithics. And when I was talking about how they were jabbing the wall with a charcoal stick and they were spitting on the wall. This is my spit. This is my charcoal. In other words, I recognize that how inadequate this image is. It's because the noosphere is something far more amazing than an image of Earth with an indication of communication connections. What we are called upon is to develop a new kind of imagination. The imagination that was developed in the caves by the Paleolithic is called reproductive imagination. And some psychologists call it conscious recall. So it was the ability, the development of the capacity of humans to consciously bring back a memory from the past. And so what I'm suggesting is that noospheric imagination is the way in which the thinking Earth is becoming aware of its development. There's this noospheric imagination, cosmological imagination. I don't know what word will capture our imagination in the future, but I'm trying to indicate that we need to break out of the constraints on imagination that were put in place during the modern industrial era. Something that you all know more about than I do, for sure. But I'm trying to connect it to the larger movement. So here, now I'm going to, I hope, provide a pathway into noospheric imagination by a discussion of the James Webb Space Telescope. And this, I start off with this picture, very radically simplified picture of the sun there, and then the Earth, and then there's a little circle with an L2 in the middle. Now, what is this about? In the 17th century, Isaac Newton articulated for the first time in human history the mathematical laws of universal gravitation. These equations have been so powerful. They are exactly what we use to fly to the moon. Nothing beyond Newton was necessary to get to the moon and back. So the equations have been analyzed by a number of mathematicians and physicists. And one of them, Lagrange, came up with an amazing insight that there are places in the Earth-Sun dynamic that are stationary. Stationary in this sense. One of them is called L2 after Lagrange. One of them is L2. So where is it and what is it? If you take a pencil and draw a line from the sun to the Earth and straight out to L2. Okay, so we move from the sun to the Earth. That's 93 million miles. Move another million miles and you get to L2. It's 1 million miles beyond Earth. Now, what does it mean to call it stationary? This is what I mean. That line going from the sun to L2, that line will be maintained as the Earth and L2 go around the sun. So that if you place something in that spot. It won't deviate. It won't go to the Earth. It won't go to the sun. It'll stay right there and travel around the sun with the Earth always between it and the sun. So what that means is that place never has sunlight entering it, which is fantastic if you want to build a telescope to measure subtle light. And so that's what the James Webb Space Telescope is. It is a sensitivity that was placed at L2 last year. So here it is. And it was built by engineers in 14 countries. Hundreds of engineers came together. Here's my main point in talking about all this. No individual could have created this. No individual human could have created this. It was those engineers, as brilliant as they are, they needed the mathematical work of Lagrange and of Isaac Newton. And all together, they could build this telescope. But they needed more. It wasn't just, they needed more. They needed teachers. The teachers had to hand down that knowledge. That was my point of going to the caves and showing how symbolic language works. All those teachers handed down that knowledge through the generations. But the teachers couldn't do that without food. So you had to have a society that provided food, and you had to have governmental officials that maintained stability. And you see, the entire human race almost is necessary, was needed. So a billion human beings, that many of them dead, a billion human beings could point to the telescope and say, we build you. We built you. It is, I'm emphasizing the collectivity of the human species because of its amazing ability to develop its mentality. Now, one last step. We have eyes, and if we want to look at something, our central nervous system sends a signal to the muscles controlling the position of the eye, and so we can tell it to position it on whatever we want to focus on. Well, with this James Webb Space Telescope, it's the same thing at a higher level. The NASA technicians send signals to the eye of the James Webb Space Telescope so that it can take in what we want to see. So the pillars of creation are what we want to see, what we want to explore. To think of what is necessary for us to have this experience. The pillars of creation are several thousand light years away from us. They require the incredible sensitivity of this advanced telescope in order to bring forth this image. Who is seeing this image? I want to suggest that it's each of us is seeing it. We are seeing it together. It's a shared experience. And it required the billions of humans necessary, and we can go beyond that. It required the stars to construct each phosphorus atom, each carbon atom that is in our bodies. So we are the eye of the noosphere. And what are we seeing? Now these the branch on the top is perhaps 4 or 5 light years in length. Now those are just words, light years. If you take the entire solar system and lined it up one after another on a line inside that pillar, you could fit thousands upon thousands of solar systems. And you can see what's so exciting for the scientists is that we can see stars that are just now forming. So we are looking at a situation very similar to the one that led to ourselves. So we are together bringing forth events from the past. I call this an event from the past because if it took thousands of years for the light to arrive here, we are looking at and becoming aware of an event thousands of years in the past. So just as the individual humans were remembering an experience of a horse, we are now, as a collective, as a noosphere, we are now remembering the conditions that brought us forth. Humans dragged boulders hundreds of miles and erected them in this shape because of their desire to participate in, to enter into the larger order of things. Stonehenge is one way of doing this. This is the Hawaiian monk seal. It's endangered, and I like to think of it as entering a plea. I know I'm personifying here, but a plea for us. What I've tried to present to you is the way in which the noosphere is satisfying one desire, the desire to know the nature of the universe. And I wanted you to think of that a Paleolithic human with our same brain, excuse me, with our same anatomy, same nervous system, looking up at the night sky and wondering about the nature of the universe. And through the development of the noosphere, we have this spectacular vision of the universe. Compare the chasm that separates our knowledge now from what that Paleolithic knew. This is for one desire. There are many desires that we have. For instance, we have a desire to educate. It's a desire that is common to humanity. It's throughout the human groups is a desire to educate the young. And I just try to imagine what will be accomplished as we join together and bring about ways of educating that go as far beyond what we know now as the James Webb Telescope goes beyond what that Paleolithic human saw. Another example, another primordial example is we have a desire to heal immediate wounds, to heal traumas from the past. And this desire is being satisfied, is finding a way forward with initiatives like Doctors Without Borders. Doctors Without Borders, they're in 70 countries now. And my hope in presenting this was to give you a sense of how the ongoing creativity of the universe, the ongoing development of the universe is directly related to the work you are doing in many, many different ways. That it's a cosmological grounding in our endeavors, which can sustain us, which can provide us with the strength we need to continue moving towards our ideals. So I know it's Friday night and you just arrived and you're tired and you're eager to take a break. But if there are any comments, insights, questions, remarks, I would love to interact with you, but I do understand that it's late. So, and I do believe that
I have a handheld right here.
the people
All
in the
right.
room will provide a microphone so I
I
can
have a
hear you.
microphone right here for everyone. Who's up?
Brian, it's Amy. Thank you so much for all of that inspiration. And I wanted to ask a question about when you were talking about.
I hope you're not talking because I can't hear.
Oh, I am.
Are you
Just a
talking?
second. Yes.
Is that Amy?
Yes. Hi.
Oh, okay, good. There it is. There it is.
I said, thank you so much for all the inspiring talk. And I wanted to go back to one thing you said about that when you were saying, the precision of the expansion, it couldn't be even the slightest bit slower or the slightest bit faster. And you used a phrase, I apologize, I don't have it exactly, but it was something about sort of purposeful order or the purposeful amount of complexity. And I wondered, are you attributing an intention of the universe to have sort of birth itself or know itself, or is there a sort of embodiment of the universe as consciousness implicit in what you're sharing?
Yeah, these are really vexed areas. It's the fact that the universe is expanding at just the necessary rate for this order and beauty and complexity to come forth is a major challenge for scientists, and it's an ongoing argument. I would say that the majority the majority of mathematical cosmologists prefer what is called the multiverse. The multiverse is an idea that there are an infinite number of universes. Ours is just one of them.
Occurring
If there's an
concurrent.
infinite number of universes, then maybe one of them is going to come alive. So their view is that we just happen to be in that universe that has life. Now, I am strongly against that. I'm strongly against that. Why? Because we have no evidence whatsoever of another universe. And so I psychologize the whole thing and say that the cosmologists that like the multiverse, they're just killjoys. I mean, we have this incredible, it's like when we're children, we used to be amazed and happy, and we have this moment of returning to a childlike amazement at existence, right? And to try to concoct an impossible explanation that involves things we will never see or know. I don't know. I mean, We live in a universe that's incredible. That to me is what's going on. And it not only wants to go somewhere, it knows how to get there. That's the third story.
Thank you so much, Brian. Everybody, please join me in thanking Brian for being with us.
Good night, everybody.
Good night, sweetheart.